Okay, everyone, sorry for the delay, a couple minutes late here, but we're here now, and can you give me a hi or hello if you are also here and if you can hear me? Can you hear me now? Is anyone here? I see 3 people in the room. Well, this could be a very short Q&A here. Okay, well, I guess no one's got questions for me. There was one question that was posted on the classroom, and that was the question from this worksheet, question 4. Wrong class. From this question, question 4, and that was as follows. 2-point objects x and y equal and opposite charges at a fixed separation of 3.6 centimeters. The 2 objects exert a force of this amount on them. What is the magnitude of each charge? And state whether the charges attract or repel each other. Okay, so for this question here, we know this fact here. They're equal and opposite charges. So what I'm going to call them is I'm going to call this Q, and I'm going to call this negative Q. We don't know what they are, but we do know that they're equal and opposite. So whatever one is, the other one is as well. Okay, we know the separation, so this is our R value, and we know the force. So this is R, and this is force. So if we want to solve the magnitude Q, then we're essentially just going to be looking at this as a problem here. So our formula for Coulomb's law is F equals K Q1 Q2 over R squared. In this case here, the only thing we don't know is the Q. So what I'm going to do is I'm going to rewrite this as KQ squared. Now, I'm going to omit the negative sign, and I'm going to give you a bit more detail why next week. For vector quantities, we kind of ignore the sign, but for scalar quantities, we don't ignore the sign. So instead of calling this Q and negative Q, I'm just going to call them both Q to make our life a little bit easier, and this is still going to be over R squared. And we just have to recognize that if they're opposite charges, then that means that they're going to be an attractive force, which is the answer over here. So they are going to be an attractive force because they're opposite, and that's what we need to keep track of, not necessarily the signs, but just whether or not they're going to go towards or away from each other. And so this is what I'm unaware of. I don't know what the Q is. So I'm going to rearrange for Q. So I'm going to multiply both sides by R squared, and I have FR squared equals KQ squared. I'm going to divide both sides by K, and I'm going to have Q squared equals FR squared over K. And if we go to calculate this out, then I'm going to have the force, which is 5.1 times 10 to the negative 5. So 5.1 times 10 to the negative 5, and we're going to multiply that by the R, which R squared, which is 3.6 times 10 to the minus 2 squared, and wait, 5. Sorry, I forgot to multiply there. Okay, so times 3.6 times 10 to the minus 2, and we're going to divide that by 9 times 10 to the power of 9. And that's going to be our answer of Q squared. So I take the square root of that answer, and I have 2.7 times 10 to the minus 9. So that's how you'd answer question 4a. Now question 4b is the charge of each object is increased by adding 2q to each object. Calculate the separation where the force would be the same as it was in the first question here, and state whether they're attractive or not attractive. So in this question here, where you're going to add 2q to each object, in this case here, you kind of do need to pay attention to the charges just to think about it this way. our first charge, so I'm going to do green pen from now on. So our first charge, Q1, was initially just Q in the first question, but in the second part of the question, sorry, this is A and B, in the second question I'm going to add 2Q to that, so now it's going to be Q plus 2 more Q is going to give me 3Q. Now for Q2, it was, in the first scenario, negative Q, and if I add 2Q to that, it's going to go to positive Q. So this is giving us a good place to start from. So in this case here, we know that F is going to be, we already know what F is going to be. We know that it's going to equal this still. And we're trying to solve for R squared. So I'm going to skip the algebra, you can do that on your own, but R squared is going to equal K times 3Q times Q, because that's what our new ones are. So Q1 is going to be 3Q, Q2 is going to be Q. So now I'm going to multiply K, Q1, Q2, gives me K times 3Q times Q divided by F, and we can solve for it there. So this is going to be K, 9 times 10 to the 9, multiplied by 3, multiplied by Q, and also multiplied by Q. Now we solved Q in the previous question right up here, it's 2.70999, etc. So I'm just going to multiply that by the answer squared. Because what I've done here, if you look at my calculator, I've got K times 3 times Q times Q. We know from the previous question Q was the answer that I had in my calculator, the 2.7 times 10 to the minus 9. So that's all good, and now I'm going to divide this by the force, which we said was 5.1 times 10 to the negative 5. And this is going to be my R squared value, and so now I have one more step to find R, which is just take the square root, and this is my answer, 6.2 centimeters, or 0.062 meters, or 6.2 times 10 to the minus 2. So hopefully that answered the one question that I had. Does anyone else have any other questions? And if you do, please put them in the comments. Otherwise, this will be a short 7-minute tutorial fit block. Just a quick reminder, next week is going to be our unit quiz. So by Friday, we'll need to have that unit quiz done, and the unit log as well. And both of the unit log you already, or the learning log you already have, and the quiz will be posted on Friday. So you'll have a full week to complete that. And it looks like there are no questions. So, guess we will see you again next week. And if you do have any questions, send me an email and let me know. Thanks.